Test 1 2. Check 1 2. Something like that.
All right. Cool. Hello, everyone. Can you hear me? Excellent. So welcome, everyone. Yeah, this is kind of a new format we're trying out. Post-COVID era of just trying to think about, maybe creating a different situation around visitors who are coming in and sharing their work. You can let us know afterwards if it's going to work out. There will be, or what we should do to improve it as we go. But we're super excited to, basically try to break out of all the patterns that we had pre-COVID and try new things. So there will be pizza after the lecture. So no pressure on Ryan to stand between you and some free pizza. But that will be delivered quietly in the back. And then, of course, at the end, please grab a piece as you move off. So I'm Jason Young. I'm Dean of the College of Architecture and Design. And it's my pleasure to announce today's speaker. But before I do that, I want to say a few words about the generosity of BarberMcMurry Architects and how it is that generosity makes it possible for us to have people like Ryan Jones teaching here in the college. So since 2013, the Charles Barber Endowment has generally enabled the college to promote design excellence by bringing nationally and internationally recognized architects to serve as the BarberMcMurry Endowed Professor in Design. The professorship is the result of a $1.2 million endowment given by both Blanche Barber and the current leadership in BarberMcMurry Architects. BarberMcMurry Architects are a Knoxville-based architecture and design firm that recently celebrated their centennial. They are very, very successful architects here locally and at the state level. This year ran the tables, in my view, on the East Tennessee AIA Awards program, and great partners to have. Previous BarberMcMurry professors have included Larry Scarpa of Brooks Scarpa, Wendell Burnett of Wendell Burnett Architects, Billy Faircloth of Kieran Timberlake, Mitchell Squire, an internationally known artist from Iowa, and Jenny Wu and Dwayne Euler of the Euler Wu Collective in Los Angeles just last fall. So Ryan Jones and Lake Flato Architects really add to pretty stellar lineup of visiting professors that just frankly wouldn't be possible without the kind of partnership that we have with BarberMcMurry Architects. And their support is really essential to my mission as dean and the college faculty's mission, which is to give students the most vivid educational opportunities that we can. So we have some members of BarberMcMurry here, Heather and Chad and Ben, and we have a student who is currently in the program and also interning there. So we're really happy to have you guys here. So with that, it's my honor to introduce the 2022 BarberMcMurry Endowed Professor in Design, Ryan Jones of Lake Flato. Lake Flato is a leader in the design of innovative, sustainable projects throughout the U.S. Founded in 1984, Lake Flato believes first and foremost that architecture should be rooted in its particular place, should respond in a meaningful way to the natural and built environment in which it participates. Using local materials and partnering with the best local craftsmen, Lake Flato creates buildings that are tactile and modern, environmentally responsible, and authentic, artful, and beautifully crafted. While the firm has grown along with the range and complexity of projects, Lake Flato has found the desire to build in partnership with the land to be an approach that remains valid and increasingly resonant regardless of the scale and the complexity of the work that they do, which is rare. The general trajectory that we're more familiar with seeing is that as architecture firms grow and as their projects become more complex and the requirements more demanding, that the early principles that really put the firm on the map to start off with begin to be replaced by other principles that are more germane to doing that level of complex work. So Lake Flato really represents an inversion of what we typically see in the field, where they've stuck to their principles, and those principles are being basically shored up by the fact that they are resonant regardless of scale, regardless of complexity. So I want you to think of that as you're seeing the work that Ryan's going to show. It's rare to, there's a lot of pressure professionally to do that. So Ryan Jones, AIA, is a partner at Lake Flato. During his 15 years with the practice, Ryan's played an integral role in the design of some of the firm's most complex award-winning projects. He has architecture degrees from Texas A&M and Rice University. His commitment to an integrated design process combined with his technical aptitude have resulted in projects that successfully celebrate the synergies between building and landscape, passive and active systems, materiality and craft, budget and performance. So with that, I'll turn it over to Ryan. Please help me welcome him to the podium. Thank you.
Thanks, Jason. Appreciate it. Yeah, I want to take a moment, and just for the students out there, I want you all to realize how unique it is to have an endowment like the BarberMcMurry endowment within your school. You know, I work all across the country and work with a lot of different schools, and it's very unique to have an endowment that large that's allowed this school to kind of bring people like me and the amazing other architects that Jason mentioned to the school. As Jason mentioned, I've been with Lake Flato actually now 18 years, and I lead our higher education studio. Today's Jason was asking me, what's the title of your lecture? I got really creative, and I said, well, my title's my agenda. So what we're going to talk about today is really, I want to show a lot of work, a lot of imagery, but I want to talk specifically about how we arrive at this work in a very deliberate way, and through an integrated design process. And so we're going to show some beautiful imagery, talk about biophilia, carbon, and the kind of mass timber in the direction we're going as an office. Lake Flato is a firm of 150 people. We have 2 offices, one in Austin, one in San Antonio. We're very Texas-based, but we work all over the country. I think this is an image that we take out at Ted Flato's ranch every year. We go to in August, in the middle of the heat in the summer. We go out to his ranch along the river, and I think we purposely do this to kind of remind ourselves the importance of shelter, the importance of architecture, and the role that it plays in engaging climate and in engaging landscape in kind of just human health. And we got our start working on ranch houses, and this is 38 years ago, and I think it's always good to remind everybody this is middle of the postmodernism era, and David and Ted kind of come in, and they're really focused on vernacular architecture that's rooted in place and connected to climate. And we always like to differentiate the fact that we work on ranch houses at the very beginning, because ranch houses to us are differentiated from just normal residential in the fact that they need to be resilient. They need to be out. They're out in the land. They're not urban environments. They're responding to landscape and responding to the breezes and kind of engaging topography, using natural materials of the land. Protecting ourselves from the northern breezes. Kind of receiving the southern breezes off the creek bed. And those kind of elements, and creating outdoor environments that don't require energy, that they kind of just use the natural resources of the climate and the earth to provide shelter. And at the same time also, transforming things that are kind of remnants, other kind of, in this case, an old cement plant into kind of a new residential compound. This is kind of the root of our work, transformation and kind of connectivity to landscape. And so I think it's really important to start there because it's really part of our ethos and who we are. And as Jason was mentioning, no matter if we're working on residential work or a 250,000 square foot lab building, we share the same values across all of our work. We are highly dedicated to the craftsmanship of architecture, really deeply kind of involved in kind of placemaking and the role that has in kind of creating delight in beauty within architecture. We are very data driven. We use performance as not just something that we hope to attain through our engineers, but we lead through kind of data kind of the pursuit of data to inform our decision process. And ultimately, at the end of the day, we as architects, our greatest goal is to build community within and play a role in the building of community and culture. So as I mentioned, we're working all over the country now. We're able, because we have such a value system that allows us to focus on the unique attributes of every unique place. What I like to always kind of say is that we as architects travel, but our buildings don't travel. And so our buildings always feel of their place. And because we aren't necessarily a form-based firm or these kind of things, that we kind of really focus deeply on understanding whenever we're working in Philadelphia that project is very different than it is in Arizona. And I hope you see some of that today. So we got our foundation in these ranch houses, but we're also doing very innovative kind of houses today when we focus on craft, technology as a form of craft. And so this is a 3D printed house that we just wrapped up last year. It's clicking really fast, to really kind of study kind of a new form of construction and really leverage the kind of the system to create texture and a new sense of environment for residential construction. We're also, whenever I talk about place, it's also transformation, as I spoke about. This was actually my very first project at Lake Flato 18 years ago, where we transformed kind of a storm swale connected to the San Antonio River into a new kind of civic place for the city. And thanks to the endowment, my students were able to come and visit a couple of these places, including this one, a couple of weeks ago. And create just new central kind of places that for people to come together. But place isn't limited to just landscape. It's also a matter of, like I talked about earlier, delight. And delight is a little bit different in the fact the way we talk about it is it's almost a surprise. It's something that you don't expect, but it kind of resonates with you and at a different level. And then we believe that architecture can magnetize space. It can kind of bring people together just through kind of the quality of space that's provided and the kind of the complexity of space. And then ultimately that it's also unique to its particular place and it's authentic. We talk a lot about authenticity when it comes to working in different environments because we don't want buildings to feel out of place. In fact, we talk a lot about how our most successful buildings feel inevitable. We strive for a sense of inevitability, that they are so deeply rooted in place that once they're built, they almost feel like they've always existed. And you can't imagine what it was like before. And I think we find that our most successful buildings achieve that. As I mentioned, performance. I mean, when it comes to building performance, understanding the complexity of systems. And I hope part of what you get out of today is understanding the complexity of architecture and the need for kind of integrated approach to kind of leveraging a lot of different expertise to execute buildings. So in this case, a 250,000 square foot lab building that required a lot of different systems to achieve 56% energy reduction as a whole. And yet still maintain beauty, still accomplish contextualism and kind of modernism at the same time. But we don't just focus on energy and carbon, we also focus on human performance and the sense of the type of spaces that we provide elevates the human experience and success, frankly, in people's work. So all this is kind of, as we kind of focused, I mean, if there's a term that's kind of developed over the last 5-10 years to kind of represent the kind of our physical connection to nature, which is called biophilia, and I hope you're familiar with that term. If you're not, I'd suggest you do some research on it. But basically, it just kind of implies that we're all kind of, our genetics and our kind of our psychological kind of understanding of space is driven very much by all the way back to the savannah and our understanding kind of living in nature and being kind of threatened all the time by nature. But it also creates a strong connection to our natural environment. And over time, as we've kind of built architecture, we've kind of built other things, we've kind of landed in a place of cubism, especially several years ago, where we're kind of stuck in these really awful, inhumane environments. And biophilia in our lens is really a way of getting back to kind of what feels more natural, what makes us happy, what makes us most productive, and just connected to nature in general. And so that's a huge part of our ethos as an office. And the very first step to understanding biophilia is to kind of go and reference the 14 patterns of biophilic design that Terrapin Green has done for all of us. And it's a great resource. If you're not familiar with it, you should go read this. This to me is mandatory reading for everybody working in architecture. And it basically talks about all the different forms and different ways that design can connect us to nature. And we always look through our projects through these lens of, kind of nature in the space, natural analogs, and nature of the space. And these kind of, I don't have time, I could give a whole lecture just on this information, but I'm encouraging just to go read all that. But it's all about taking spaces like this that we've been stuck with over several years. And I can't tell you how many, as a higher ed person, I can't tell you how many classrooms I go into across the country look exactly like this. And we look for opportunities to kind of reconnect them. Even though this isn't an amazingly expensive space, you can just tell the kind of the connectivity that it brings back to nature as a whole. But there's also kind of using natural materials, water, kind of all this kind of engaging kind of porches that engage the landscape, daylight, all the kind of stuff that you've heard your professors and everybody talk about over the years, the way that it kind of shapes space. We talk about buildings being shaped by light and shaped by landscape. And what we mean is that it's a major driver of where we put program, how we shape roofs, and everything. You can kind of feel that in all of our work. At every level. So, I think that all comes from a place where you have to realize, and I had a professor one time tell me this, that the older I get, the more I realize how little I know. And the point is that you have to really lean on the expertise of other people to achieve really high aspirations for your architecture. And so we focus very heavily on bringing together diverse groups of people very early on in the process, which includes our clients, our engineers, landscape architects. Some of our best ideas come from people who are outside of the project, other faculty, and bring them together to talk about the project in a cohesive manner, and very early on in the process. And we do that through the lens of talking about things like ecology and water, energy and air, light, materiality, resiliency, equity, diversity, inclusion, like these topics, and we do these charrettes geared around these topics and focus on them and think about the project through the lens of those issues. And there's an extensive process we go through in documenting this. But the point is that we're kind of always looking to gather information, right? Gather opinions, gather data, gather different perspectives, and in some cases even history. The image on the top left was actually brought to the table. It's a historical stream bed that shaped one of our buildings that was brought to the table by a member of the community in one of our community meetings. And through this integrated process, my students have seen this, that we try to define what the goals and aspirations for the project are at the very beginning. And we do that through the lens of what we call SMART goals, which are goals that are very specific, and they're measurable, they're aspirational, they're attainable, they're relevant and timely. But the point I'm making is that they're not just, we want to build a beautiful building. They're very specific about what we're trying to accomplish and how we define what success looks like. Because the clarity of your goals, it really matters. And because what it happens is you need clarity of goals in order to kind of build consensus and belief in your project amongst a large group of constituents. Most of the times in your career, you're not going to be dealing with unless you're working in residential, with just one person. You're going to be trying to keep 20, 30, 100 people happy, and it's very difficult. And so the way you do that is you develop buy-in through very clear aspirational understanding of what you're trying to accomplish. And then on top of that, you keep track of those goals throughout the lifetime of the project. So they don't just die at conceptual design. You go back and you check on it throughout the entire, through SD, DD, CDs, all the way through. You always go back to these kind of goals that you established very early on, which is why these goals are really important. And this process is key because the other thing you'll find whenever you get into the profession is that your ability to impact your project fades with every day that goes by. Because every day that goes by is kind of another opportunity where you can't go back and make a change. And so pushing all this integrated design process, these goals, these decisions that we're making very, very early on in the design process, you want the smartest, best, most capable people at the table at the very early of the project, not at the end. Because at the end, you can't really leverage that knowledge base to really have an impact on your project. So I want to encourage you to kind of just be very aware that the need for collaboration and integrated approach in architecture as you move into the profession. And I think it's our focus on this really deeply integrated design process that integrates both beauty, what we call about the art and science of architecture, at the very first stages that makes us kind of one of the more successful, sustainable kind of design firms in the country with 14 AIA Top 10 awards, which we consider kind of the highest honor within our profession is to kind of receive these awards that the AIA puts out. And we've managed to do that across a lot of different sectors. So I thought I might just quickly kind of go over a project that I think kind of summarizes this impact really quickly of integrated design. And it's Confluence Park. And Confluence Park is an outdoor pavilion that we designed at the confluence of two waterways in San Antonio. The original design was kind of this conceptual idea of just a shell. It's very form-based. It's interesting. It's been done 100 times, but it's interesting. It's kind of fun space to be under. And what we found is as we started thinking about with our artists and our engineers, what we're really trying to do is we're trying to protect people from water. We're trying to also at the same time collect water and kind of understand the shape of that and how it could kind of form a building that would kind of function in both ways at the same time and be a physical representation of kind of the collection and movement of water. And so, we worked with artists and kind of structural engineers to kind of understand how we would fabricate what we call the petals to kind of accomplish these. So each one of these petals are the exact same, but they're distributed in a way that creates an interesting biophilic form that's a kind of educational about the waterway. So constantly collecting water and so on. So even though it's not, it's shaped and it's kind of, it feels like petals and it's kind of along the waterway, it's really kind of also a ceremonial destination. And so, that's only accomplished if you really have a good technical understanding of concrete and kind of form making and all the other kind of skill sets that are required to really execute a kind of project of this order of magnitude. And, as well as constructability. So these were all we had a mold that was fabricated in Austin. These were cast. This is actually a temporary kind of setup, mock-up, and they were cast in Austin. They were shipped to San Antonio and then placed in place, all hung. It was all erected pretty much in just a couple of days. Yeah. So some of it's just beautiful imagery, and we'll share some of that today. But all of our almost all of our, we call EcoCon, which is our ecological conservation studio, is really focused on education. So all these moments are always opportunities to be demonstrative and to celebrate the unique kind of role architecture can play in connecting us to nature. So let's Lake Flato. So I want to shift a little bit and talk about where we are as a society in general. And I have a friend at SQ Dumas Ripple EDR out of New Orleans, Z Smith, who's a really amazing individual, and he and I we always run into each other at conferences, and he gives this presentation, and his start to his presentation is basically the end of world discussion, is that the world is ending. It's burning down. We are dealing with severe climate change, severe global warming, and he's right, and it's very end of days kind of thing, because it's meant to scare you, and it's true. That is all going on, and it is something we have to deal with, and we have a responsibility in this room to deal with that as we move forward. The way we talk about it is that there's a reality about population growth and expansion within our world, where basically we're building 230 million square feet of building every month for the next 40 years. That's the equivalent of basically building Manhattan every month for the next 40 years. Okay, it's absurd. Think about that. I mean, that's crazy to think about. And so that has a huge impact on the way we think about our impact in terms of construction and architects, and the fact that 39% of CO2 emissions come from buildings. Okay, so 40%. So it's huge. It's not, I drive an electric car. I love my Tesla. It's great, but that's not where the impact's coming. We're having the impact elsewhere in our 40%, and it's not just in carbon. It's also through, it's also through all these kind of other impacts that are kind of beyond the site that's a whole nother presentation I could give just on the impacts that we're having beyond just carbon and global warming potential. So sometimes I always feel like it's important to kind of start with what's causing global warming. Okay, greenhouse gases are basically causing a blanket above the Earth's crust, right? That normal solar radiation is coming down. Normally solar radiation bounces off and goes back into the atmosphere. Okay, that's the way it's meant. That's the way Earth is meant to work. That's the way it was designed to work. And now these greenhouse gases are basically creating a blanket, which is keeping that solar radiation from moving back up into the atmosphere. And it's trapped basically and creating, that's what's causing kind of global warming. So that's just real quickly, that's really important. So there's two pieces that we want to talk about. One is that there's two elements about global warming potential. We have embodied carbon and we have operational carbon. Okay, we're going to focus more on embodied carbon today. Embodied carbon is basically the amount of energy and CO and kind of that it takes to extract, manufacture, construct, and even dispose of down the line any material that we build with, whether it's concrete, gyp wall, whatever it is, mass timber in our case, what we're going to talk about today as well. And the reason embodied carbon is becoming more and more of a focus is because we need an impact now to kind of to stem off global warming. Like, we don't need it in 50 years. We need it now. And so whenever we look at this graph, to the left, embodied carbon has impact today, right? Operational carbon is how we're going to use energy down the road 10, 20, 50 years from now, right? And that's extremely important. But we need impact today, and that's why embodied carbon is vital that we kind of address that. The other reason embodied carbon is important is because over the last 10 years in particular, we've seen technology and kind of an interest in sustainable design has made it more efficient buildings. Our operational carbon in buildings has come down significantly and as it continues to go down, if embodied carbon doesn't change over time with this image on the top right, it's going to be the bigger piece of the pie that we've got to address down the road. So as buildings become more efficient and operational carbon comes down, the embodied carbon piece is more and more important. I'm going to skip through this because we got to get going. But as we can move forward, so you can tell here, whereas previously operational carbon might have been 75% of the overall carbon use of a building, now it's moving more and more toward 50-50, which is why you're seeing people like Lake Flato move toward more of a focus on embodied carbon. So in the embodied carbon pie, if you will, of the carbon aspect of a project, structure makes up 56% of the embodied carbon within a building, okay? And that's really important to understand. So the biggest impact we can have on the embodied carbon of a building is through being very critical of our structural systems in some capacity, all right? And of course, there's other impacts here that you have to think about as well. Everything has an impact, right? But structure has the biggest impact. And so as I mentioned, the other ways are, we can reuse, resalvage to reduce embodied carbon. We can kind of assess kind of the cement makeup of our concretes. We can kind of use bio-based materials. We can reduce interior maintenance. We can also, but the one that we like to talk about a lot is we can dematerialize our buildings. A lot of times we find that people just are applying materials just to gussy them up, the lipstick on a pig kind of mentality, right? You just kind of to clean it up. Whereas we've always kind of really appreciated the raw nature of structures and the exposure of systems and the dematerialization of buildings, removing things that are superfluous, right? And I think that's another strategy that's really vital. So to assess kind of embodied carbon, we use a program called Tally. Karen Timberlake kind of actually created this several years ago and have shared it with the larger community. And it has it's got its quirks, but in general, it does a really great job of just assessing kind of things like understanding this is basically the global warming potential of different kind of siding materials. And so once again, we think about data kind of informing design decisions and starting to think about, well, if we're going to clad a building in granite, it's going to have a huge impact that we're going to have to make up somewhere else or make a better decision. Or we're going to need to find a more efficient way of building with granite in this case, right? So in this one, we're assessing on the far right, basically what it normally call a 4-inch granite stone piece versus a 1 1/4-inch veneer. And the kind of impact of that based on mass and scale, obviously, is that it's reduced by over 50%. So my point in saying all this is that kind of we have to actively seek out data to inform our decisions, right? A lot of this is intuitive, but data is kind of a major driver in our design process as we develop decisions about even things like insulation. And just FYI, XPS insulation, you'll get into this later when you get in the profession, but it's really bad stuff. You really should try to avoid it as much as possible. The other thing is that even within kind of decisions like using concrete and steel, some of these materials actually have huge ranges. Some of them can be fabricated really sustainably and have very low global warming potential. And then the same product can be fabricated in a really poor way and have a really high global warming potential. So I think as we transition to talking about steel, about mass timber, I think the thing about steel is steel can actually be fabricated in a way that's actually fairly sustainable. But the problem is that it also has a huge range. They can also be fabricated, in China by an unsupervised plant that's then shipped to the U.S. on some, in really kind of poor ways, and it can have a really huge impact. And so just being aware that some things are more controlled and have more oversight than others. And so I think what that all comes down to is really kind of maybe focusing more on regional materiality as we think about this. So we're going to transition to talking a little bit about mass timber here. And what you're seeing here is basically an assessment of kind of the life cycle cost of mass timber versus steel. And just understanding that what we found over multiple projects at this point, we've done, I think, 10 mass timber projects at this point, that we're finding that mass timber operates at usually hovers around a 50% reduction in global warming potential over steel, or under steel, whatever you want to call that, which is a big deal. And it's a big deal because if we're able to continue to this rate of doubling the amount of mass timber buildings built every year, we'll be basically carbon neutral as a society in the next 10 years, next 10, 12 years, which is huge. And I think that's why I appreciate hearing that the schools focus on mass timber. We're seeing so much growth in mass timber, so much more interest. It's critical that they continue to be part of our kind of skill sets of design as we move forward for this reason, because there's so much ability to sequester carbon within mass timber that we want to leverage. Okay, so what is mass timber, right? I think that just to clarify, what some of y'all may not even know what mass timber is. So there's heavy timber, or stick frame, which is like 2x4s. Go to Home Depot and buy your 2x4 kind of thing. That's not what we're talking about today. But there's heavy timber, which is kind of just large logs of lumber, old cabins, that kind of stuff. But then you have mass timber, which is basically glue-lam strategies, which are smaller pieces of wood glued together to create larger structural members. And the reason the smaller piece is really important is because it allows for the forests to be more sustainably harvested, because you're able to harvest much smaller trees to fabricate much larger elements, which is crucial. So like a company like Nordique out of the Northeast in Canada, they harvest like 6-8 inch trees to fabricate all their glue-lams, columns, and beams. And versus like having to kind of harvest a huge 30-40 inch live oak, that's not really what's going on here. We're harvesting much smaller kind of elements that make it much easier to sustainably manage forests. Yeah, so smaller members, they're kind of pressed in this way. This is a CLT panel coming out, but there's different products. So there's cross-laminated timber, nail-laminated timber, dowel-laminated timber. Those are kind of the primary elements out in the market. We'll talk about this specifically in a little while. They are coming out with mass plywood solutions that are out there as well. That we're doing a residential complex in the Northwest out of mass plywood. But there's only really one manufacturer that's doing that right now. And they all have different aesthetics. But basically, these are the two main products you see in the market: dowel laminated timber, cross laminated timber. And the whole idea is that they're just 2x6s either laid on top and doweled together, or cross laminated. And the great thing about cross laminated is that they act basically as a two-way concrete slab, which means they're structurally kind of. I'm sure there's someone more experienced in this school than I am on this, but the main point is that they act as a two-way slab, which allows them to cantilever in different directions than a dowel laminated timber does at that point. And we're actually leveraging that capability on a project for A&M right now. If you haven't been to the Cadita building at Georgia Tech, I highly suggest you go. There's actually a lot of great work on Georgia Tech's campus. Between Miller Hull, BCJ, Lake Flato, in EDR, there's some great architecture on the Georgia Tech campus. But one of the things that they did that was unique to this NLT approach, this is nail laminated timber, is they were actually able. I love the story. Brian from Miller Hull loves to tell the story. It's great that they basically were able to get local tradesmen to fabricate the NLT on site. And these are people that didn't have jobs before this was done. So they were able to kind of create a more community-focused let's say job supply chain, if you will, to create the kind of NLT for the building, which is a great story. So it's not terribly complicated. And I think the other piece that's really beautiful about mass timber is that it comes together very seamlessly. There's very little waste. It's very precise. It's got a smaller on-site workforce. And what's great about this is that I'll talk about that in a minute. So you end up with these very clean spans of mass timber. Well, it's wood, so it's got to burn, right? So everybody's worried that it's going to fall down because it's burned. And what people need to understand is that mass timber, it has what they call a char layer, which allows basically the amount of kind of fire rating needed for mass timber is how thick that char layer has to be, which allows for you to meet all the fire ratings of code and compliance. So it's actually very likely that a steel building is more likely to fail than a mass timber building in certain circumstances. And so that's really key to understand. And as mass timber has grown, I think this is really important to y'all, is that we're seeing plants pop up in Alabama and in Arkansas, and they'll be in Georgia before you know it, all over the country. Because basically, what's happened is we're now able to use southern yellow pine as a species for mass timber, which 6 years ago wasn't really viable. And so you're starting to see an interest in kind of the growth of this kind of product in different regions. And every manufacturer has their own unique take on things. What we found is that the thing to focus on when it comes to mass timber is how it's sourced and where it comes from. And I think the way it's harvested really matters. It can't just be harvested in an unsustainable way, and to accomplish the goals that we have for carbon neutrality. So this graph, we don't have time to get into it, a lot of detail on it, but what I want you to take away from this chart on the right is that the global warming effect is greatly reduced whenever it's grown and harvested in a sustainable manner. And if it's not grown and harvested in a sustainable manner, it almost doesn't have any impact by comparison to steel, and that matters. So whenever you're thinking about specs and being critical of your process, you need to be aware that that's the case. But most of the great manufacturers in North America have that kind of well done. So great. So now we know what mass timber is. So I want to give I got two more things. One is I have two projects. If we have time for both of them, great. If we don't, it's fine too. But I want to start with Trinity University, which is a project that we just completed. In fact, we just opened it 3 weeks ago, that we did for Trinity University in San Antonio, Texas. And O'Neill Ford was kind of the father of architectural modernism in Texas. In fact, David Lake and Ted Flato both worked for O'Neill before they started Lake Flato Architects. And little context, Trinity was originally master planned to be like the Princeton of the South. It was meant to be a very formal campus, and which is a very northeastern kind of attitude about coming down to Texas and building a campus. And O'Neill pushed them away from that and said, no, this needs to be a whole new place of learning, a whole new way of creativity and experimentation and so on. And because of his deep roots in understanding nature and kind of landscape and craft, he really pushed the campus more toward this kind of these east-west bars that were really directed toward responding to topography. It was an old quarry, so it kind of lines the edge of an old quarry, and kind of really defined outdoor rooms in a very informal way versus a very formal quad way. And it kind of created a whole new ethos of what a campus can be in Texas. But O'Neill was also very interested in structural innovation, and all the buildings in the very early days, him and his engineers kind of invented this thing called the lift slab system. It was basically just slabs were kind of poured on the ground and lifted up into place. And at the time, it was very, very innovative. And so there's this heritage of structural ingenuity on the campus that really made kind of mass timber an interesting topic for this campus. So we were tasked with basically renovating 2 existing O'Neill Ford buildings and adding a new building down here on the northern end of campus, which is on the bottom of the page. And we also had to shoehorn in 10 different departments, 130,000 square feet into these kind of 3 structures. So programmatically, it was very interesting to find ways to of leveraging, maximizing the kind of space that was already existing and in the renovation, while also adding new building and kind of giving everybody a sense of identity within this complex. But the new building here on the northern edge was really was placed to define the edge of campus. It was also placed to terminate a long axis, which was the kind of approach from the central quad of campus on the right, but while also creating an identity of a district around a courtyard. And so just this simple east-west bar managed to accomplish all these different kind of landscape gestures within the project. We are also pursuing Texas Historic Commission tax credits. Got it. All right, there we go. Which meant that in our renovation, that basically 10% of the budget of the project was coming from the Historic Commission's kind of pocket. But that came with a lot of restrictions in terms of architecturally what we could do. And they wanted it to very much fit into the campus, even the fact that the new building couldn't be taller than the building immediately adjacent. So we worked a lot with them to kind of really define the character of the building, to kind of fit in and create and define a district within the northern edge of campus. And really it was set up in an east-west bar that really focused on a central spine that runs down the middle, which we call the academic spine, which is right down the middle. And all the academic programs on the east side, because they're the more public programs, they're part of the front door on all three levels. They're considered kind of part of the front door to not only the community, but also into the campus. And then more of the student-centric departmental spaces were on the west side along the courtyard, which felt more like it focused on the identity of the courtyard and created a sense of cohesion amongst the departments. So this skinny east-west kind of oriented bar, kind of doing mass timber, I think one thing is we accomplished 55% reduction in embodied carbon. We're sequestering enough carbon that basically the equivalent of 830 acres of forest. So just in the one decision about mass timber, we were automatically able to accomplish some pretty amazing kind of metrics. It's also the first 100% mass timber vertical construction in Texas, which means that we were able to accomplish all of our shear walls, all of our core walls, everything is mass timber. There's a lot of buildings out there that use concrete or CMU block or steel for their lateral bracing and kind of cores. This is 100% mass timber kind of vertical construction. And creating kind of student-centric spaces that were kind of adjacent to the courtyard. The other thing about the east-west kind of orientation of the bar is that it's kind of set up to maximize kind of solar kind of protection. We are accomplishing 78% of our energy demand through our PV array. But the more important thing, the passive design strategy, is that we were able to put all of the transient spaces, the hallways, the porches, the transient zones that could have a much wider spectrum of temperature range. We were able to locate those on the south elevation, where we had less control of kind of heat gain, and place all the more kind of regularly occupied spaces that have tighter temperature zones on the north side of the building. And that one move allowed for us to basically build in a buffer between solar heat gain, which is our primary problem in Texas, and the kind of more controlled spaces on the north. In majority of Lake Flato projects, I haven't seen a project that was less than 90%. Almost all of our projects have 95% of our, or more, in this case 98%, of our regularly occupied spaces with access to view and daylight. Very rarely will you find rooms in Lake Flato projects that don't have a window, don't have daylight. It's not common. It's just against our ethos. It doesn't. So whenever we do our early planning strategies on buildings, it's just a huge part of what we focus on. In order to maximize the potential of the mass timber, we chose to go to a raised floor system for our air conditioning and heating demands of the project. And what's really, we made all these decisions a year before COVID hit. And I think it was one of the things lessons we learned is because in an underfloor system, basically it's a pressurized plenum underneath the floor that pushes air up from below as opposed to pushing air down. And so since hot air wants to rise, the air moves naturally up and then it's ventilated off the ceiling. Before COVID, that wasn't a big deal, but after COVID, basically the whole idea that you're moving pollutants up out of the zone versus pushing them down into the zone became a huge part of one of the strategies of how you create healthy interior environments. And so So that was really, really important. It also is typically about 10 to 11% more efficient than a normal kind of air conditioning system. The other thing is it allows for us to clean the ceilings, right? On the images on the right, much cleaner kind of systems because we don't have a lot of duct work and so on. But it also allows us to put all of our conduit, AVIT needs, all that stuff below in this plenum space, which allows for long-term adaptability, which is really important. The biggest drawback of a raised floor system is that it isn't, it's noisy. I mean, it's not as solid as a concrete slab, for instance, and that bothers some people and some clients. But a very, very effective way of getting very clean, kind of organized structure up above. Yeah, and then we got water stories going on as well. So like I said, we just wrapped this up a couple weeks ago. In fact, our marketing department took some photographs. We haven't had it professionally photographed yet, but you know, here's some imagery of the completed project. One of the challenges with mass timber is the species. So most mass timber comes in Doug fir and spruce pine fir. Those are your two most predominant species. Now we have yellow pine, which is becoming more predominant. And so matching to Doug fir with all the other wood finishes in a building is actually very challenging. So just be aware that whenever you start dealing with mass timber, the matching of wood species can be challenging. In this project, we chose to match everything to Doug fir as much as possible. For some of the other people in the room, like we used western hemlock, Doug fir, and red oak flooring. So that was kind of the species mix that got to these kind of warm pinkish hues that you get with Douglas fir. So we did some, as part of this, now at the end of our project, we kind of did this analysis. We did this during the process as well, but we did a carbon analysis and basically comparing steel to mass timber. And we had our structural engineer go back and basically give us a design for the building as if it had been steel. So we knew exactly what the members would be for the most part. So we could get apples to apples comparisons of steel to mass timber, and we can do a deep dive analysis of the two systems. And what we found is that basically that our global warming kind of impact went down about 50%, but that's due to the amount of sequestered carbon. So I think I do want to talk a little bit about sequestering carbon. So so basically, if mass timber is kind of, it's a tree, it's out in the forest, it's operating as a cleansing mechanism of the atmosphere in itself. It's cut down, it's turned into a log, it's put into a building. It doesn't release any carbon for the lifespan of its existence until it's burned. The only time it releases carbon whenever it deteriorates or it burns, which is why end of life is so important. We'll talk about that. But it also, by removing the tree from the forest, you're allowing another tree to take its place, right? So the thing that people forget is not only are you sequestering carbon within the building, but you're also offering a new opportunity for carbon to be kind of sequestered in a new tree that can then be sequestered as well. So the regenerative quality of mass timber and wood is a really pivotal part of why it's so important. So the thing that we found in doing these analyses is that the piece in the tally that actually, remember that software I was talking about, that's really not developed yet, is that people don't know what to do with mass timber at end of life. In our book, end of life for mass timber would be like any Amish barn. It would be basically debolted and re-erected somewhere. That's the way we look at it. But if it was end of life was just to turn into thrown in the trash or kind of get burned or whatever it is, that would have a huge impact on the carbon kind of analysis of the project, right? Because it's no longer sequestering carbon. Now, in our condition right now, we're delaying that carbon until a later date when hopefully technology gets us to a place where we can deal with it in a new way, right? That's the goal, is to buy us time for technology to catch up to the problems that we're dealing with as a society. And we did this kind of analysis for mass timber versus steel across the board on all the different ways that buildings impact steel. Impact our climate. The other piece is that we took that same model and we analyzed the cost, because everything's like, oh, it's too expensive. You'll hear that from clients all the time. It's too expensive, all this stuff. And let me just show you the analysis. What we found is for a building with the finishes, if wood was part of the finishes of our building, it was cost neutral. The structure, if we look right here, the structure cost of mass timber is 26% higher than steel. The structural cost, okay? Over the entire budget of the project, structural cost, that differential accounted for 3.3% of the overall budget, okay? Well, if they want to build a steel building with sheetrock and ACT, and they need to be at that price point, that's one thing, okay? That's one thing. But if they're trying to build a typical kind of higher education building that we find across the country with wood finishes and so on, I think what we showed was there's basically no impact. So it's basically the comparison of these two images, right? So that 3.3% represents the savings between the image on the right and the image on the left. So I think what we're talking less about it being more expensive than we are about level of expectation of your client, if that makes sense, right? And if your client expects a quality product, then in our opinions, there's no cost differential, because we're not having to apply all kinds of new materials to get to these finishes that we already have with the structure. And that's the real point that we make whenever we have these dialogues. So anyway, so just more comparisons. The other piece that we're saving 2 buildings, we're salvaging 2 buildings as well, right? And I did want to mention that in terms of while we're talking about carbon, embodied carbon in particular, we're keeping by renovating existing structures, which I think is going to be a huge part of where the profession needs to go for the next 50 years in particular, because we're going to have a ton of mid-century modernist, and brutalist, frankly, architecture that is going to need kind of work and kind of to be have lives extended on in the immediate future. And the point that I want to make with this image is that just renovating a building isn't enough. Like, you can actually do a renovation and have really bad impact on the environment if you don't do it well. And so what's happening here is a retrofitted building down here in the orange. If its EUI is really significant in terms of its operational energy and its trade-offs and everything, that top line carries up. It can perform actually worse over time than building a brand new building, okay? And but ultimately, the ultimate end game is to basically salvage buildings and have them be really highly efficient operational energy-wise. So that can be difficult. Sometimes with older buildings, it's really difficult to get them to be really efficient structures. And so in the carbon, we did analysis, and basically, this is to scale. This is why we did this. If we're saving kind of 50% of our carbon footprint here on mass timber and green, right? That one decision. By reusing and salvaging those 2 buildings, we're also kind of saving that other percentage of global warming potential out of those 2 other structures. So the combined impact is very significant. If this was 830 acres, then what is that? Like another 1,500 acres or whatever it is. It's a pretty significant amount of acreage that we're preserving. So one piece I want to mention is we're adding a whole new building and only increasing the entire and retrofitting 2 existing structures, and only raising the energy use of that entire district by 1%. So that's a pretty remarkable thing. The EUI, for some of y'all, for the EUI on the new building is 10.6, which is, I think a normal building of that scale would be like 60. It's a really high performing structure and building. So I thought I'd share some kind of construction photos just to understand that this whole building was erected in I think 2 months, maybe 3 months, by a team of 7 people. It's just very few people working on it. It's really remarkable to see them. They all get delivered on site, all CNC routed. What you're seeing here, the brackets here on top of this column, you can see on that beam on the top right how they've routed out the connection joint out of the mass timber element, and it just slips down on top and gets screwed in with two long screws, and it's called done. I mean, it's really remarkable to see them erect these things. These are the shear walls that were installed that I mentioned earlier that are very unique for mass timber in Texas in particular. where we just exposed the kind of CLT shear walls on the interior of the space, and created like enclosures for like the stair, which is all CLT as well. In terms of the new stairs. You do get water damage during construction. It's normal. Wood's okay being wet as long as it doesn't stay wet. As long as it dries out, it's totally fine. I think that's the piece that people always worry about. Oh, it's going to get wet. It's going to get wet. Well, as long as it dries out, it's not a big deal. And what we find is that these kind of staining and the stuff that you get through construction before it's enclosed, they all just sand right off. And it's really remarkable how easy. No, easy. It's not easy. It still takes work. Somebody's out there doing it. Don't get me wrong, but they sand off and they look beautiful whenever they're done. The same with like penetrations. Whenever like the same penetration on the left that we had to cover up, that the repairability of mass timber is really unique. We deal with concrete all the time, and it's very challenging to get repairs in concrete to feel as kind of clean and beautiful as this. So I love showing this as Carrie, our project manager. So I always say, come hug a tree with us. If you want to come to San Antonio and visit, shoot me a text, an email, we'll go take a visit. We'd love to have you. Jason, Carl, do we have time for one more, or are we good? Yeah. Okay. Okay. Let me just breeze through this real quick for like 5 minutes, just show some imagery and not talk too much. And so we're working on a data science building at University of Pennsylvania up in Philadelphia. We'll skip this. Their whole thing is it's computer science building. They wanted to reconnect people back to nature. They wanted to be computer science, but they wanted to be biophilic at the same time. And they also wanted to be a destination that kind of linked. This is a great Wife's Manfredi building on the left, the Nano building. That's their main hub of engineering. And they wanted, since they were off kind of the main axis of engineering, they wanted to be a destination and wanted to be unique. And they kind of had this site next to a garage that we had to come in. So what we did is we built a 6-story structure, which is the first 6-story the first mass timber building in downtown Philadelphia. But it's going to be 6 stories, which actually maxes out the code compliance of exposed mass timber. There's some nuance in there, but at 85 feet. So it's a very big deal for us to kind of build a building this scale. And the ground floor really wanted to be a welcoming space, really a front door that also communicated the diversity of programs in the building. And so as you come in, you're immediately greeted by not only mass timber, not only volume and daylight, but also views out into the landscape, the community, and the street. And so it's organized in a way that the academic programs are down low, the research programs are up high above, and showcasing all the stuff. And then also within the research, there's also these collaboration zones that were really kind of part of what drove the facade and comparisons. And so we end up with these kind of organization of the facade and in response to interior program with these breakout spaces along the perimeter. But the unique thing, we had this great vision for these huge sunshades and stuff, and it got feed out, of course, and so we kind of pivoted to another strategy that really dealt with frit as one of the main solar protection strategies. And the frit was really meant to respond to kind of different things. One, like natural kind of graining of wood, leaves, kind of the kind of circuitry of electrical engineering. It really looked for ways to kind of take this aesthetic and make it performative, because the frit actually reduces the solar heat gain impact and the glare of the building. It's actually a dark colored frit. And we were able to work with both the engineers, the artist, as well as our design team to really kind of create these layers of kind of how the organization of the frit would occur in response to program, daylight management, kind of the mullion system, the window system, and all the different kind of light levels that are required. Because some areas wanted more deeper penetrating light, some wanted very short, very kind of muted light, and kind of responding to all those is really what the criteria that we worked within our script to really define the frit pattern, which this is the mock-up that was just completed a couple months ago as it works across the facade. Yeah. One of the reasons they chose to go to mass timber, not only because of the warmth and the kind of biophilic nature of it, but it was also because they're downtown Philadelphia. It needed to go quick, need to go quiet, and it needed to not impact traffic a whole lot. So you can imagine if you're going versus concrete, you're going much quicker. You get out of the rest of the community's way. It's a big deal, especially when you're building like at Trinity, where you're building right next to a neighborhood. and you have a construction process that's significantly quieter, think about how much fewer complaints you have as a university whenever you're dealing with that. So that matters. We actually saw a 70% reduction at Penn on our carbon. We're doing an exposed system of mechanical systems at Penn. A lot more challenging, but we've had to work really hard to kind of get all that organized, and there's a way to do it. It'll be beautiful when it's done. So last thing I'll leave you with, if you are interested in mass timber, if you're not familiar with Structural Lamb's Mass Timber Technical Guide, great place to start. Great place to start. This has a lot of really great information about grids and sizing and all kinds of things. So great place to start kind of understanding mass timber if you're interested. The other one is Woodworks. Woodworks has a lot of really great white papers on mass timber covering everything from like protection of mass timber during kind of construction to like insurance requirements for owners. So very wide spectrum of leadership. And as my studio knows, we talk a lot about architecture. We talk a lot about beauty and imagery and all these amazing things, but I also want you to really, really successful people in our profession. And so I always like to kind of bring up some of what I feel are some of the better books to read to really kind of help you just grow as an individual. And Seven Habits of Highly Effective People is kind of a great starter point. If you haven't read that, Good to Great is a Bible that everybody should read if you want to kind of go from good to great. Start with Why by Simon Sinek is a really great way of focusing your goals and what you're trying to accomplish. And Think and Grow Rich, it's not about making money. That's an awful title for that book. It's about living your life with intention and being intentional about what you want to do with your day and where you want that day to take you. So don't misunderstand the title. The title doesn't tell the full story. But anyway, so yeah, I can't tell you enough how thrilled I am to be here, Jason. Thank you all so much for your time. And here's my contact information. Text me, email me. I'm always here for you. Thank you.
Okay, so we have some time for questions and answers here. You want to?
So you answered part of my question with like repairing and I'm sure transport for mass timber can be hard, like stuff getting banged around, which that was cool to see how easy it is to do that. But my second part of the question was, is there any kind of learning curve for contractors and guys putting this stuff up that's like weird that you've run into, or is it fairly straightforward? It seems fairly straightforward, but.
It is straightforward, but anything new is new, right? So they don't know what they don't know. And so, it's very common there's two type of contractors, right? There's the contractor who really knows what they know. They really enjoyed kind of doing their thing. They don't want this mass timber thing is something that's just, it'll never be in the budget. Like they're very dismissive of it, right? But the reality is those aren't the contractors you want to work with, right? So you try to avoid those people. But what I've found is actually, and I think we're very lucky this way, is that the contractors who get hired to do these jobs are the ones who see the future coming. And if they don't, they're missing the boat because like architects, anytime we see this all the time, there's a certain project type that'll get hot within the market at any one moment. Right now it's student services and computer science, all these kind of things, new recreation facilities. They get hot within the moment, and if you don't get ahead of that trajectory, you're gonna get left behind. And so what I find is that the contractors we work with they're actually very passionate about it, and they're very kind of interested. And so I think the way that you overcome that is that you have them talk to each other. And so what we do now is if we have a contractor that we're getting paired with that doesn't really, he's just say a naysayer, then we try to give them a couple other contractors to talk to that we know have done it before. Because what we found is like once they've done it, they realize, oh yeah, it makes my life easier in so many ways. It makes it more difficult in others in terms of coordinating MEP and electrical and stuff. That gets more complicated for sure. But that's always been complicated in Lake Flato work because we've always had it exposed, whether it was steel or concrete. It didn't matter. I don't know if I answered your question, but yeah.
Another question here.
Yeah.
So you were giving us lots of great examples of how you reduce embodied carbons, but I had a question, say in Trinity, how do you reduce operational carbon in the running of the building?
Yeah, so wasn't part of the conversation today. It's always a huge part of who we are, and it always starts with passive design strategies. So we don't, we feel like kind of technological based kind of energy reduction is kind of a band-aid for other decisions, is the way we think about it. So basically, if we can make better decisions about passive design strategies, right, maximize the impact of daylight harvesting, kind of protect ourselves from, in our case, most of the time, intense Western kind of solar heat gain. You know, if we can set up, like I talked about, what I call passive programming, which is like placing programs in places that actually create stronger synergy between the climate and the program. So for instance, in our case, we were kind of placing all the transient spaces on the south elevation to buffer heat gain. I do a lot of STEM buildings as well. So in STEM buildings with labs in particular, you have ventilation rates where you're basically ventilating the air so quickly that there's no impact on the heat gain of the project. So leveraging spaces with high ventilation rates along the perimeter of buildings actually helps buffer the impact of the climate on the interior space. So the point I'm making is that I could go on and on about passive design strategies, but it always starts with the way you site a building and where you place program in response to the climate, and where you're going to put the maximum kind of glass and kind of what we call window wall ratio in your building. So it always starts there. And then we go through, and then in the process, we've already kind of accomplished a big reduction there. Then we go into kind of understanding mechanical, electrical, plumbing systems to really get into the weeds about what the project can afford and how we prioritize those systems, sometimes over finishes. I mean, there are plenty of times in Lake Flato's work where we said, well, we have to have this mechanical system because we need a higher performing system, and we're willing to give up something that a lot of other architects wouldn't give up, frankly. So you have to be, there's a balance to architecture that we look for. We don't want any component of our building to feel, I don't know, more special than any other. Like to us, it's all uniform. It's all uniform in your approach. So I'd have to give you a whole nother hour-long presentation on the rest of it, but it always starts with passive design.
Now that you have more experience working with CLT as like a structural system, has it impacted when you are doing initial form finding and spatial interaction?
Yes. Thank you for answering that question, asking that question, because Lake Flato, like we've never, like I think Confluence Park isn't really a great representation of. It is a great representation of Lake Flato, but we're not form makers. We have always traditionally thought more about the craft of just the what we call ranch tech, which is just using kind of commonplace materials to create architecture. And whenever you get into mass timber, in order for it to be cost effective, efficient, all these kind of things, it needs to be more pragmatic. It needs to be, there's a rigidity to it. There's a grid that needs to be kind of leveraged. It's not that you can't build beautiful, like, kind of mass timber buildings. That's not what I'm saying. What I'm saying is that most of the time in the profession, if you're you're fighting the battle to get it in the project, and then whenever you compound that with, kind of really kind of complex form making or complex geometries, you're compounding the problem. You're working against yourself in your argument. And so, I think what you would find across most of our mass timber projects is that we let the structure drive a lot of the form making about rigidity, and we embrace the simplicity of it. Because there's an elegance to the simplicity of mass timber. Whenever it gets complicated and you have big chunky members that start doing quirky things and they're exposed, it gets messy really fast. It just feels unorganized, and so I think there's a challenge to it. And yes, it does impact the way we think about our building completely. So.
Yeah, I wanted to ask about your insights about earth architecture especially in wet climates, wet in terms of precipitation. I know it's not the central subject for us today, but the possibilities or the opportunities for use for earth architecture in more wet climates where there is more rain, and what types of management for working with the protection from the water.
Whenever you say earth architecture, can you define that a little bit better?
Well, the architecture that uses earth as its main construction material, maybe rammed earth,
like rammed earth,
CEB, compressed earth blocks.
Yeah. We've done 3 rammed earth projects at this point. They're all residential projects. To your point, they are in kind of deserty climates, Utah, Arizona kind of spaces, and so I'm not sure I have the experience to answer your question, to be honest. I don't know if I'm the one to answer that question, to be honest. So I apologize. So.
Okay, maybe is there one more question? Do you want it?
So you mentioned inevitability and delight as like 2 of your goals and values in the buildings that you build. And to me, those 2 things seem to contradict a little, especially inevitability. I feel like that can translate to boredom. And so I'm wondering how you hold both of those in the same hand, and like what design decisions do you make to implement both of those at the same time?
Yeah, I don't think inevitability means predictable, if that's what you're getting at. I think there's a complexity to inevitability that is, I feel like the High Line's inevitable. If anybody's been to the High Line, I wouldn't say the High Line's boring. It's not void of delight. It's not of those things, but it also feels like, could this have ever been anything else other than this? No, I mean that's exactly what it should be. So I don't think there's. I think the point that we're striving for is that the connection between program, site, architecture, and landscape kind of works so seamlessly together that they feel, they just feel like that's really the only way it could be. I think delight is. Delight's a hard thing to design for, and most of the really great delight moments actually are accidents. They're not intentional because they aren't. It's really difficult to design them, and because they're surprising, and because architecture is a very structured and very methodical and and it has a lot of constraints. Unlike art, for instance, it has a lot of constraints, real restraints. That it's hard to create delight, which is why it's usually accidental. And you try to insert it as much as possible. You try to make space for delight, and you can kind of be intentional about it. But I would say that I don't know what else I could elaborate on in this time frame, but I'd stick to that for now. So.
All right. Ryan, one of the cool emergent qualities of your talk is that you've been talking about biophilia as you've danced with that tree there.
I know. It needs a swing.
So thank you very much. I appreciate your delivering that lecture and bringing your perspective and your energy into the school. Thank you to BarberMcMurry Architects, the folks who are here, but also the folks who aren't here, for allowing us the opportunity to have practitioners like Ryan intermittently part of our program here. It's a great differentiator for us. And before we give a last round of applause, just a couple of notes. A lot of things were moved into this space and moved out of this space to make it happen. There's probably a review here. Looks like there's definitely a review in 103A. If you can, in addition to grabbing a slice of pizza before you go, also help move the chairs back if your review is in there, or if you know a friend who's having a review in there. There are no chairs in there. All the chairs are here, which is help us help one another, which is a good thing to do. So with that, thank you, Ryan.